Assalamualaikum and very good morning. My name is Mohd Aiman Haqim. Today I will talk about my project for subject EET 208 Electrical Power Technology. It's about analysis of three-phase wire connected generator. So let's get started. So in this presentation, I will go through these four parts. There is introduction, methodology, the way I found, the way I collecting data, the what actually I'm doing in this project. Next is the findings, the results, and the last one is the conclusion and the discussion. So the first one is the introduction. So as we all know, three-phase system is actually an economical way of bulk power transmission over long distance for for distribution. It can be connected in delta or star. So three-phase is consists of three-phase voltage source connected to a three-phase load by means of transformers and transmission lines. So the connection it has several types. It actually have four types. So this different type connection it can give different amount and characteristic of it on output. If the connection of is the type default connection is this. So the first one is the delta connection. This connection is generally used for large low voltage transformer. Next one is the YY connection. So this connection that we are using in this project. This connection is generally used for small high voltage transformer. Next one is the star delta transformer. It is mainly used in step down transformer at the substation and of the transmission line. So step down before the voltage supply before it reach our house. It usually this transformer they are using to step down the voltage. So the last one is the opposite of the star delta is the delta star. It is a step up transformer at the beginning of the transmission line. So the objective of this project is first one is to evaluate the parameters of the electrical system according to BS 7671 or any Malaysian authority standard. Next one is to analyze and evaluate the active power absorbed by the loads by using 2-watt meter method and conventional method. Last one is to prove the normal operating condition and validate it by using simulation. So for information, the type of software for the simulation part I have been using is the PSIM software. So the methodology, the way I collecting data, how I done this project is so first the collecting data. We have been assigned the specific data for each and every one of my members in this group. So from the emission we complete the objective with all the data given. So for example, me the line voltage is 275 kilovolt with the base frequency is 50 hertz. So transmission, the impedance and the transmission and the load impedance are from my metric number. So next, I've been through the calculation. I already applying all the formula from chapter 1 to get the desired value such as voltage phase and the voltage line, the line current, and also the power apparent power. So next, I'm going to the simulation by trying an error, and by looking in the YouTube, I was able to do the configuration in the PCM to get the value from simulation. So next, analysis, comparing all the data from both sides, from the calculation and the simulation, comparing these two data. It must be, the objective is it must be the same. Then last but not least is I'm doing the calculation, carry out the outcome from this task and learn to solve problem that been given. We going through the findings in calculation and simulation. So this is all the calculation I've done. So as you can see, this is the impedance that I have, the transmission and the impedance I have been given. So I have to change into Henry so I could use it in the PCM software. So as you can see here, this is the value I've got after rearrange all the formula. So I also been assigned the voltage line 275 kilovolt. So this is the my transmission loss from the metric number. So after doing transformation from polar to imaginary, so I steadily assign the Z total for easier my calculation. So next, this is the I phase current. So by in, insert all the data I've been given, so I managed to get the I phase current. So next, since the I phase and the I line current are same in the YY connection, so I just took the value. So this is one of the characteristic of the YY connection. So if you are having something you want to do with the transformer, so you have to know the characteristic of the connection that you have chose. This is the current phase load. So this is the formula, I line current times with Z load. So I managed to get all the value from the formula and so from the data. Next is the V drop percentage percentage percentage. So this is the value we have learned, the formula we have learned. So we just uh, after complete all the data needed, so we just simply put it in. So I managed to get the 25.36% of voltage drop. So the last one is the active power absorbed. So since the power is same, so we have to times 3 the active power. So from the formula here, I managed to get 150.09 megawatt of active power. So I've times 3. So this is the total active power for my project. Next is this is the compared value that I got from my simulation and also my calculation. So my lecture told us that we have to get the value is almost the same for both calculation and also the simulation, but you can see here my measured value from the simulation are different, almost about 60 kilovolt different between these two. So next, my line current that I got from for both sides is most similarity. So next, this is the voltage phase that I have, the comparison I have got from both sides. So as you can see, it is a slightly a small difference. It's about 1 kilovolt between the measured and the calculated value. Next is the 2 wattmeter method. So for calculated, I have got 450.27 megawatt, and for the measured from the simulation PSIM, I got 444.78 megawatt. It has a different but a small difference. So next is for my conclusion. So throughout this task, the value between the calculation and the calculation and the simulation are different. Based on the data calculated, voltage line in the simulation shows a large difference with a calculation where almost 60 kilovolt. And what I've find out this maybe come from the lack of knowledge me using the PCM software. So for the calculation is throughout this task, I this me can configure, create and analyze the electrical system. We also can learn and see the parameters of electrical system according to the BS7671. Last but not least, I have successfully managed to obtain all the desired value from this task. That's all from me. Thank you and selamat hari raya. Maaf Zahir dan Putih.